Today's topic is why in-app parallel bidding is so important, and is it really the edtech do-over? What parallel bidding is, what does it mean, why we need it, and how it's, more importantly, how it's going to make our world better. So, as I said, today we have Andrew Flack joining us, and he's going to be a panelist. He is a director of product here at Appodeal and has been working at parallel bidding for a very long time now. We first started thinking about it last year, about maybe a little bit more than a year ago, and we started working on it back then and started testing in May this year. So we already have a first exciting result, and more importantly, we are going to ease you into understanding what parallel bidding is, why it is important, what advantages can you take from it, and so on. So hi, Andrew, please say hi and introduce yourself to all the attendees.
Hi guys, my name is Andrew Flack. I'm product director in Appodeal, and I'm pleased that we have so many attendees.
Great. So today's agenda is going to be, you'll receive today's agenda, but today's agenda you can see in the slide. So as I said, we're going to ease you in the technical background of the parallel bidding, and going to talk about models, different models where parallel bidding can be used. Is it the only way to be using parallel bidding, or there are other ways to use it, and also how exactly this has increased the value of the impressions, value of the traffic, and of course the revenue that it brings. So let's start talking about this. So let's go in and dive in. Andrew, can you please tell us exactly what parallel bidding is, why is it important, and how we are basically making the world better?
Sure. So to first talk about parallel bidding, I first need to talk about the model that is used by mediators all over the world right now, and it's the most used model for mediation for quite some time. So that is obviously Waterfall Model. So the main difference between parallel bidding and Waterfall Model is that in Waterfall Model, ad requests are made sequentially. So we make requests to the first ad unit. If it doesn't fill, we go to the second. If it doesn't fill, we go to the third. Parallel bidding is a major game changer here because it changes how we work with Waterfall, or Waterfall is not present here exactly. So instead of making requests sequentially, in parallel bidding, we made requests simultaneously. So if we have 4 ad units participating in a parallel bidding auction, we send requests to them at the same time and waiting for their response. So this is parallel bidding technology is not new. It's new on a mobile application market, but it's been in use for quite some time in mobile web, and it was known as header bidding there. So parallel bidding is a new iteration on the header bidding technology that makes it adjusts it and changes it a bit to work with mobile application. As you know, because header bidding in mobile web are built on headers of web page, because such things are not existent in mobile applications. Parallel bidding readjusts Waterfall Model to work with parallel requests. So Waterfall Model is super useful. It's useful. It was useful. It generated a lot of revenue for a lot of publishers for many years. And parallel bidding is a new iteration and new major change in mediation that's right now being developed by and starts being used by a lot of publishers. So to reiterate, the biggest difference between parallel bidding and Waterfall is that in Waterfall requests are made sequentially, and in parallel bidding they made simultaneously. So to describe how parallel bidding works from technical background, Natalie, can you change the slide?
Thank you so much. Just before we're going to go so deeply into the technical details, I just want to say that in Appodeal, we actually did start with publishers. And we worked before 2014, before 2015, before we started, we worked on a traditional waterfall basis with just a few networks, and that was the only way available on the market. So as Andrew said, we would test our traffic, or we would test our networks based on the historical ECPM and historical performance, and we would just send the traffic to those networks, and that wasn't working that as well, just based on that. So the parallel bidding is brought into the market to basically make it better, make it automated, but more importantly to engage the ad networks into the real-time auction and enable the networks to see the requests, the ad impressions before they fill them, to understand what is exactly value of this impression, and is this something that they're looking for, is this something that they want to pay a higher price for. So that not only increases the value of your traffic for ad networks, but that also increases your revenue and how much you actually can receive for that the same amount of traffic, or for that same amount of daily active users that you have, without doing any extra work. Before we dive into the next slide, I just want to remind everyone that today we also will be doing the Q&A session at the very end. So please feel free to ask questions, and you can see ask question and raise hand button on your Zoom platform. So go ahead and ask any questions. We will address them at the end of the session, at the end of the webinar. I also will be running polling. It will be very simple polling, asking who you are, to understand your interest better, to understand the audience better, so we can address that in our future webinars. So that was a little side note. Let's move on. So Andrew, back to you now. Let's focus on the technical background of the parallel bidding. So what exactly, can you tell us in a few words, how does it work technically?
Yeah, so on this slide, you can see a simplified model of how parallel bidding works, and more exactly, how would it work in ideal situation when only parallel bidding is used in mediation. So an app makes requests for an ad from Appodeal SDK. Appodeal SDK sends requests to our servers, and our servers conduct parallel bidding auction. So parallel bidding checks the list of all networks that participate in parallel bidding, sends a request to each of those networks simultaneously with all of the data that our Appodeal SDK can collect about the impression. So that would be like device data, user data, and stuff like that. Obviously, everything that we are allowed and to collect, and what end user consented to collection. Each of the networks then assess the data about the impression and decides whether they want to bid on that impression or not. And if they decide to bid, they each give back a price, the ECPM specifically, that they are willing to pay for that specific impression. Appodeal server collects all of that data from all of those networks, selects the higher winning network, if there are any. For example, in this example, as you can see, the network with $15 ECPM won the auction. Appodeal SDK server sends that information, so name of the network, some specific identifiers for the creative, and the price back to our SDK. Our SDK then loads an ad from the winning network using identifiers the network provided, and that's pretty much it. When publisher wants to show an ad, he just calls a show method as usual, and the winning ad is shown. And over the next cycle of outloading, when publisher wants to show a new ad, we conduct parallel bidding auction again and again until the app is closed.
Okay, well, it sounds like sounds very engaging for the ad networks, and sounds very profitable for the publishers. So in the ideal world, this sounds amazing, and I hope that this will actually continue improving, and bringing everything to the game. But how about the non-ideal world, you know, in our current situation? Because we all know that we don't live in the ideal world. We have wars and stuff. But in edtech world, we actually still are relying on the historical performance. Are we able to coexist? Is parallel bidding able to coexist with the traditional waterfall and flat waterfall and everything else? Or this is the only thing that we rely on right now?
Yeah, so obviously parallel bidding being a very new technology, despite it being used for a couple of years now in the mobile web, because the technology is new to introduce parallel bidding capability, ad network have to make a lot of technical changes on their side. So while this technology is being adopted by a lot of networks right now or being developed by a lot of networks, most networks still have this technology in beta, or some of them haven't released anything at all. And so while parallel bidding obviously brings a lot of positives, we still have to rely on traditional waterfall model in some way, because traditional waterfall is right now still the major source, or more specifically, the networks that are working in traditional waterfall are still being the major source of impressions and revenue for publishers. So in Appodeal, we introduced what we call hybrid model, where we merge parallel bidding, auction, and traditional waterfall model. So this slide describes how we implemented that. So before conducting traditional waterfall request, we first conduct parallel bidding auction, determine the winning price, if there is any. So in this example, the network with $13 CPM won the parallel bidding auction. And then we check our traditional waterfall and see, are there any networks with ECPM that is higher than the networks that won parallel bidding auction. In this example, as you can see, we have two bids, two ad units in the traditional waterfall, $15 and $14, with ECPM that is higher than parallel bidding bid. Next, we conduct a traditional waterfall request. So we request first network from the waterfall, the second network from the waterfall, and only in the case when those two networks didn't fill, we automatically fill the network from parallel bidding auction, because its CCPM is the highest amongst remaining ad units, and that ad is presented to the publisher to show it to the user. And if in this specific example, if the second network from traditional waterfall, the one with the CPM of $14 won, we would load that ad and show that ad to the user, ignoring the network that won parallel bidding auction. And in this hybrid models allows publisher to get the best of both worlds. They either get the highest paying ad from parallel bidding auction or the highest paying ad from traditional waterfall.
So let me get this straight. So in this hybrid model, we actually give the priority to the parallel bidding auction, right? And then we move on to everything else.
Kind of, but not exactly. So while we do request ads from parallel bidding auction first, before going to traditional waterfall, this is done to get a precise price that the network will pay for that impression, and then we use that price to position the parallel bidding winner in traditional waterfall.
Okay, I see it now. Oh, also I wanted to mention another side note. I can see here in attendees that we have Dmitry Usakov joining us. And just wanted to say that actually Dmitry was one of the first employees here at Appodeal that started also working at parallel bidding. And it's too bad that he is unable to join us with a voice. Maybe we can try. Dmitry, can you hear us? Can you say a few words? I guess you can't. That's too bad. Anyhow, so thank you so much, Dmitry, for joining, and thank you everyone else. So let's move on to the next slide. now that we all understand clearly that we can coexist, parallel bidding can coexist and happily operate with hybrid model, with traditional waterfall and flat waterfall and everything else. Can you tell us, aside from the obvious advantages, the higher revenue, right? What else, what kind of other different advantages and expectations can be placed based on the parallel bidding technology?
Yeah. So the main advantage that obviously leads to increased revenue is that each network that participates in parallel bidding auction can compete between all other networks for each specific impression. As I mentioned a couple of minutes ago, because parallel bidding auction is conducted first, the networks participating in parallel bidding auction have unique chance to bid on each specific impression, while in a traditional waterfall, the network can only bid on specific impression only if all of the networks higher in the traditional waterfall, all of the networks in traditional waterfall didn't fill. So in parallel bidding, all of those networks can bid simultaneously, and this this allows them, or more specifically, this allows publisher to get higher price because networks that compete between each other have an incentive to pay more if they really want the specific impression, because they know that we request ads in an auction environment, and that impression can go to any other network. The second advantage, as I mentioned, is, so first advantage is each network can bid for each impression. The second advantage that flows from first one is increased competition. And increased competition obviously leads to higher revenue. And the third advantage is reduced latency. So in traditional waterfall, we move to the next ad unit in the waterfall only after we waited and received no fill from previous ad units. And in case when waterfall can be quite long, like 20 ad units or 30 ad units, receiving an ad from that waterfall can take some time, like minute, 2 minutes. And if your ad session are quite low, or if you show ads very often, sometimes you want to show an ad and it isn't there because latency is high and ad network SDK doesn't have a chance to load the ad yet. Because in parallel bidding auction, all requests are made simultaneously, we don't have to wait for all other networks to respond. We just make all of the requests and wait a couple of seconds for the response, and then we load an ad. And in this case, latency is reduced significantly. During a test, we see a reduction of latency of 50–70%.
Okay. You keep saying latency, you keep saying simultaneous bids and increased competition, but those statements sound a little bit controversial to me. So if everything happens at the same time, right? Yes. And everything happens with increased competition, so there are a lot more members or a lot more competitors trying to bid for the same exact impression. Why exactly latency decrease? I mean, I understand the technical background that you just explained, but exactly why, how come it doesn't make the SDK, or it doesn't make the auction really, really heavy?
Yeah, so the main reason for it, in parallel bidding, the process of the auction is moved to servers. The auction itself is not done on SDK, so it's not influencing device almost at all. SDK just sends a request, all of the heavy load of conducting auction between all of the participants are done on the server side, and only after the auction is done, server just gives SDK one network to fill, instead of conducting a waterfall between 30 participants, for example. So in this case, because all the heavy load is moved to server side, latency decreases.
Okay. So even though everything happens simultaneously, and even though we have increased competition, we still decrease the latency of the waterfall itself. Got it. So I'm sorry, did I miss it, or did you actually say like how much does it how much does it decrease the latency? What is a average?
Yeah. So during a test, we saw the latency of our waterfall request decreased by 50 to 70%.
Okay. Wow. Are there any seconds that you can quote? Like
Unfortunately, no.
Okay. Moving on. All right. So sounds good. So as I mentioned earlier, we have started testing the parallel bidding technology in May. So in May, we performed the first results, and first of all, we started, of course, in beta testing, and we had volunteer apps that volunteered to test parallel bidding with several networks that developed the technology to adopt their network technology to participate in parallel bidding. We already received first results that I hope that Andrew can walk us through. Andrew?
Yeah, sure. So this first slide shows a performance of the ad network in two stages. So the first stage, marked in gray, is a stage when network only worked in traditional waterfall model. The second stage in red shows the network after we added that network to our parallel bidding auction. As you can see, there is a significant increase of impressions for that network, and this is mainly because when we move the network to parallel bidding auction, the network receive an ability to bid for a lot more impressions that it could during traditional waterfall model. So as you can see, we see here that increase of almost 3 to 4 times in amount of impressions for the networks. And that's why parallel bidding is also beneficial to ad networks and not only to publishers, because it allows them to compete for much more impressions.
Okay. Any other results in terms of growth of participating
networks? Yeah. On the second slide, you can see, I imagine all of you are waiting for, increase in money. So as you can see, we enabled parallel bidding. So this is the same application. So this graph shows increase in ARPDAU for the app itself, for the whole app, not only for the networks that participate in parallel bidding. And as you can see on the graph, enabling parallel bidding increased ARPDAU by 30%. And unfortunately, it's not on the graph, but eCPM was also increased by 17%.
Okay, so I see that there are only rewarded videos and video interstitials participating in this parallel bidding. Is the other ad formats just not able to participate, or are we just not testing it right now?
Yeah, so it's a very good question, and it's mainly because the networks that we added for our first iteration of parallel bidding was mainly video networks, but all formats are in our future releases. All formats will have enabled parallel bidding. Well, right now, all formats have parallel bidding support. It's just that we only have 1 or 2 network working in parallel bidding auction in other types, while in rewarded video and video interstitial, we have much more. And to follow up on that, we are, as Natalie mentioned, we already have a release of SDK that supports parallel bidding. And right now we are working on new release of parallel bidding SDK that more than doubles amount of network we support. So we are moving closer and closer to that ideal world you mentioned.
Ideal world, ooh, utopian. That's great. Yeah, that actually phrase just knocked the question out of my head that I had before. So you mentioned that we are rolling out new networks joining the parallel bidding. So is the parallel bidding SDK going to be available to the public, or is it available right now?
Yeah, so parallel bidding with Parallel bidding SDK, this first iteration of our parallel bidding technology, which is SDK 2.4, is available to the public for quite some time now, and a lot of our major publishers have it already integrated. The new parallel bidding SDK, the second integration of parallel bidding technology, is closer to the end of its development, so we're hoping it will be released quite soon. But if you want to try parallel bidding now, you can always integrate the SDK that it's on our site, and we're hoping you would like the results.
Hope so. So yes, the SDK with parallel bidding enabled already available on Appodeal website, and you can just go to appodeal.com/SDK and download the SDK that already has the parallel bidding enabled. Anyhow, we are moving on. Looks like we reached the end of the material that we have prepared. And of course, if you guys have more questions for us about parallel bidding, feel free to type the questions right now. Or if you are not watching, and if you are watching this as a recording and you're unable to ask a live question, please go ahead and send us a question over email. You can use my email. It is natalie@appodeal.com, or you can use an email that is hi@appodeal.com, and we will be happy to address your questions. So Andrew, are you able to see the questions that we have in the Q&A session right here?
Yes.
Great. So there are currently we have a few questions, and if you can help us with a few of them, that would be great.
Yeah, sure. So the first question is mentioning that Appodeal sends too many network requests, and it has a negative effect on performance in terms of battery consumption, network usage, and other stuff. Aren't there any way we can send one request to backend and it will send us the best ad opportunity based on the information provided in the request? Very good question. So as I mentioned before, in traditional waterfall model, we send which can consist of 30, maybe 40 ad units. We have to send requests to each of them specifically from the device, because most of network SDK or network SDK sends the requests to the servers themselves. And because of that, it does indeed have some impact on the performance. And parallel bidding actually helps with this problem. So parallel bidding works exactly as you described here. So in parallel bidding auction, we can only send one request to Appodeal server, and that's it. Appodeal server then conducts a parallel bidding auction, and our servers send all of the requests to those networks to get a best ad from them. We send all of those requests, get a response, decide the winner, and send back only one ad unit or one ad that our network, our Appodeal SDK will then load. So in this case, we reduce the amount of we reduce the network usage, and we reduce the battery consumption because we're making less network requests. So parallel bidding is the way to go, and with more networks moving to parallel bidding, the less network requests we have to make directly from SDK, and we can move them to the server side.
Andrew, before you move on to the next question, I'd like to remind the attendees to please ask questions in the Q&A section, not in the chat section. I can still see the questions that come from the chat, but I'm unable to make sure that we answer them all. So if your question still hasn't been answered, please go ahead and copy paste it to the Q&A section that you can see on your Zoom webinar platform. So just another question from the Q&A is, with banners, has a better performance with parallel bidding than Waterfall? So yeah, you mentioned different types, and anything you can share about the banner results?
Yeah, so with banners, as I mentioned before, we only have very few networks working in those non-video ad types. And so while we couldn't conduct a decisive test, because, well, you can't run a decisive test with so few networks, we saw an improvement in impressions for those networks that participated in parallel bidding auction. And while I think the results with banners would be as good as results with videos, we'll be conducting an additional test with banners and other types after we release on USDK to make sure that it has the same or better improvements.
Okay, so that means stay tuned and we will find out.
Yeah.
So we have Rachel Bascata, I hope you pronounced your last name right, asking us, is the parallel bidding the same as the header bidding?
Yeah, hi Rachel. So header bidding is a name that is very specific to the web or mobile web, because in header bidding in mobile web or web, you conduct the auction is in very similar ways than in parallel bidding, but that auction is conducted in header of the web page. And because headers are non-existent in mobile applications, it made sense to us to rename header bidding to parallel bidding because it's just more clear. But essentially, technology is not the same, but very much similar.
Excellent. That has been marked as answered. I hope that it has been. Martin Schmidt is asking, why not running all bids in one unified auction within the parallel auction and not running another waterfall after? Well, I see not enough to fill all the bids, but Andrew, please fill us in.
Oh, sorry, I will read the question because my internet just disconnected for a bit. So Martin asked, why not run all bids in one unified auction within the parallel bidding and not run another waterfall after? So it's what you described is quite similar to our hybrid model. So all of the bids that can run in an auction style, so be it that network, be it that the networks that participate in parallel bidding, or DSPs that participate in OpenRTB auction, all of the bids from which we can get real-time price participate in that first unified auction. And only after that unified auction is finished, we conduct the waterfall request until from the top to the price that we get from that auction. So it's quite similar to what you described.
Thank you, Andrew. We have a question from an anonymous attendee. In order to compare parallel bidding and waterfall model, I think you should run the test at the same exact time where half users will be using waterfall and half users will be using parallel bidding. That's how A/B tests and experiments should be done. Otherwise, we can have wrong conclusion because we are testing in different dates, which can have completely different circumstances.
Yes. So yeah, while we done some internal A/B tests, we decided to do the test in a way that in the way that we've shown here for one specific reason. Unfortunately, for now, we are not able to correctly split the revenue between. So if we have the same, if we have user base split in two, and one user base uses parallel bidding and the other doesn't, we can't split the revenue between those two groups correctly. While we are planning to do this kind of A/B testing once we get parallel bidding up and running, because in this way almost all of the networks will move to ad unit setup if they can. When we have that set up, we can then split revenue on ad unit basis and then check the revenue for each specific ad unit. So right now we can conduct this A/B test due to technical reasons, but we are planning to conduct it in the future.
Thank you so much for your answer. We have one more question, and it's about the difference in technology between Iron Source and Appodeal. So, Andrew, have we tested the technology of our competitors, like and partners, evidently, like Iron Source?
Yeah, so as I mentioned, so this technology is very new, and a lot of other networks and a lot of other mediation are working on it. And while we didn't conduct the tests of performance between us and our competitors, this is something that we are looking closely to and monitoring how they perform and what technology they implement. Just be ahead.
Thank you. Oh, we have questions popping up like mushrooms after the rain. So
That's great.
yeah, it keeps coming. Great, you guys. We're gonna run out of time before we're gonna answer all the questions. I hope not. Anyway, so our next question will multiple placements with different floor prices still be needed after switching completely to parallel bidding?
So if we switch to ideal implementation of parallel bidding, multiple price floors will not be needed because the network can just, you send a network request for an ad, and network decides how much they want to pay. So you don't need to send multiple requests to that network. You just send one request without any price floor. But because there is no unifying standard of parallel bidding implementation, everyone implements it a bit differently. For some network, we still do need to have multiple price floors. For some networks, we moved away from price floors and just use one request. So in ideal world, different price floors are not needed, but right now we still use them in parallel bidding. Hopefully, in the future we'll get rid of them entirely.
Hopefully, that's the future utopian land that we're all gonna live in. Anyway, I had a question that I answered by typing it, but I just wanted to say it. An anonymous attendee is asking if we can share the slides and the recording later on. So yes, as I said in the beginning, this webinar is being recorded, and we will send the recording in a few days after it's ready, along with the slides. So you are able to watch it and rewatch it, even if you are not attending today. But still, thank you so much for attending and asking the questions live. Anyway, before we say goodbye, we are going to answer a couple more questions. And one of them is, will the SDK size become way less or lessen and decrease since we don't need to have all the networks adapters in the SDK?
Yeah, so there are two types of networks that starting to work with parallel bidding. So some networks decide to move completely S2S, so server to server for parallel bidding. And so we just send them requests. They send us an ad, either it being in MRAID format for interstitial or banners, or VAS format for videos, or just assets for native ads. And Appodeal SDK will handle the rendering of that ad. In this case, we can remove the network SDK from our mediation SDK, and it will indeed decrease its size. But some networks decide that it's better for them to handle the rendering of the ad because they have a lot of additional features that are not supported by MRAID or VAS formats. So those networks, while not handling the request of the ad, initial request of that, when Appodeal server says that this network won an ad, we send a request in code to that network to load an ad and show an ad. So in this case, network SDK is still needed and can't be removed because the network SDK is responsible for making an impression, tracking that impression happened, handling the clicks, and displaying that creative. So the SDKs of those networks can't be removed, unfortunately.
Cool. Thank you, Andrew. I think that we have answered all the questions. At least I don't see any new ones. So I hope that we were able to answer all the questions, and I hope that this webinar was useful for you and as it was fun for us. And I hope that we will see you guys later in our future webinars. If you, as I said earlier, if you have any more questions left, please go ahead and shoot them to my email, natalie@appodeal.com, or just simply use our generic mail, hi@appodeal.com. You can also use the intercom chat button on the site, and we will be happy to address your questions. Please go ahead and also shoot us any suggestions for the webinar, the topic that you would like to for us to cover. I appreciate any suggestions that come through the email because I want to create more productive content for you that you want to hear, not that we want to talk about. So please go ahead and shoot me those emails. All are welcome. And Andrew, thank you so much for taking time, and thank you for answering all our questions. I hope that this was a productive webinar for you as well. And
you're welcome.
And I know that we're going to see you soon in our future webinars.
Yeah, so thank you, Natalie, for having me, and thank you guys for participating and for all of your questions.
On this note, we're going to say goodbye, and thank you, everyone, again. We will see you again soon. So I hope that you have a great day, a great evening, night, whatever time zone you are at. So goodbye.
Bye.